Hey folks, welcome back to another video. Today we're looking at question 413, arithmetic slices. The way we'll be approaching this problem is by checking the condition that we need for it to actually know that it's arithmetic and keeping a count of the current sum. When I say current sum, I mean how many times we've actually seen the current sum and the total sum itself. So let's look at a quick example. So there will be two variables that we need to keep a track of. We need to keep a track of current, which would keep a track of how many times we've seen the current difference that we're looking at, and the sum itself, which would be the total number of arithmetic slices. So let's look at this example right here. We have 1, 2, 3, 4, and 5, and then you can make 6 slices out of this. So let's quickly talk about that, right? So we have 1, 2, and 3. 1 slice, 2, 3, and 4. Second slice, 3, 4, and 5. Third slice, 1, 2, 3, 4. Fourth slice, 2, 3, 4, 5. Fifth slice, and then sixth slice is the whole thing. So we have 6 slices. So how do we make that work, right? So we will be starting with index 2, since it has to be at least 3 elements, and then we check, oh, is the difference between all of the 3 elements, is that the same? If it is, we use the current counter as 1, and we have the total to be, the sum to be 1, which is the total. So let's just clarify that so that it's easier. And then we come to the second index, which is 2 plus 1, which is 3 right here. And then we see that the difference between 2, 3, and 4 is also the same, and we can consider that to be the same difference because the difference between 2 and 3 is the same as the difference between 3 and 4. However, 2 and 3 was previously used for the previous slice. So with that in mind, we know that we can make use of the entire thing that we've seen until that particular index for various slices. So you would increment total, the current to be 2, and then the total would be the previous total plus the current value that you're looking at. So it would be 1 plus 2. So this becomes 1 plus 2. And then when you come to the fourth index, which is the last index, we see that the difference again is the same. Since the difference between 3, 4, and 5, the difference is the same. And since we have used the difference between 3 and 4 for the previous sums, we know that this sum has previously prevailed, which means we can use the previous elements that we have seen for the pattern. Thereby, you'll increment the current to 3, and the total will become the previous total plus current, which is 3 plus 3. So which is 6, and you return 6. So that's how this problem works. So let's quickly read this mathematically. It's honestly not too hard once you get the idea in your head. So let's get the size first. So a dot length, and we'll have current, then we'll keep that to be 0, and we'll have total, and we'll have that to be 0 as well. And then we have the for loop, which starts with 2, goes all the way to the end of the array, and you would increment I, and then you check, hey, if a of I minus a of I plus 1, if it is equal to a of I plus 1 minus a of I minus I plus 2, oh, actually it'll be going the other way, since we're actually starting off with 2, we would be looking backwards instead of forward. Cool, awesome. So if we see that the difference is the same, you would increment the current value by 1, and the total value will be equal to the value of total that you've seen previously and the current total value. If it is not the same, you'll just reset the value of current to be 0. And this pattern continues. So in the end, once you've gone through the for loop, you just have to return the total. Alright, so let's quickly run this and see if it's okay. Right, the first test case is okay. Everything else is okay as well. Awesome. So let's quickly talk about the space and the time complexity. The space complexity is of n, since you're going through the for loop just once, going through all of the elements just once. And then the space complexity is of 1, since we're not really using any additional space throughout our solution. So that's a problem and how to solve it. If you have any questions, please let me know in the comments below. And please don't forget to subscribe. I would really appreciate that. See you all in the next video. Peace.